Welcome, everyone. Today, we're diving into the intricacies of Game Manager, a crucial component when dealing with large volumes of data in your projects. Let's explore how to effectively manage this data together. First, let's visualize the process. Imagine our player interacting with the game. For instance, when the player collects a coin, they signal the Game Manager, and "I've found a coin, please save it for me." Now, the Game Manager assesses whether the task is simple or complex. Since collecting a coin is straightforward, it's considered a small task. Accordingly, the Game Manager triggers a function. However, when the player achieves something significant, like winning a game, it's time for a bigger action. In such cases, the player informs the Game Manager, signaling the importance of the event. The Game Manager then executes a significant function, such as win game or lose a game, through the Action Manager. Now let's see how we can implement these concepts practically. Let's create a pickup trigger system for player using TAD system. Now create a new strict Game Manager. And write public function update coins that will be called by player when triggered a coin. Now save the coins count. And create instance of Game Manager, as it can be accessed anywhere without any reference. But keep in mind there should be only one instance. Now create a new script UI Manager where all the functionality of updating UI will be performed. Now create a new public function update coins text. Now it's time to call update coins functions from Game Manager as GameManager.Manager.Update coins. Now get reference of UI Manager in Game Manager, a call function of update coins text from UI Manager. Call function we have recently created in UI Manager, and give current coins to show in text. Let's design a player and some coins. So as you can see, we only called update coins function from Game Manager, and it automatically called UI Manager to update text counter. This is how we can manage data, as each script will do its own work for which it is designed for. You can add more items like play audio, Now, these are small functionalities. But how if there is a bid scenario, like lose or win? For this, let's create a new script name, Action Manager. Create Unity events like on win and on lose, and also create public function as win and lose to call on based on requirements. Get reference of Action Manager in Game Manager, as only Game Manager will give reference of any script. To make things streamlined, now create a scenario of win and lose. For now, I will use trigger. Create new canvas of win and lose. Add Action Manager script. Let's set hierarchy to easily find scripts in Canvas. Now you can add easily any action in Unity event using inspector like me. I want to disable and enable some of items when win. Like gameplay should be disabled and win canvas should enable. And same but lose should be enabled for lose scenario. Now create triggers for win and lose. It is time to check the functionality. In more complex scenarios, like displaying winning animations or handling transitions, we can rely on the Action Manager to streamline the process. By organizing our code in this manner, we not only ensure smoother gameplay but also create a structure that facilitates collaboration among developers. In conclusion, mastering the Game Manager and Action Manager setup is crucial for handling large amounts of data in your games effectively. Thank you so much for watching this video. Please give me feedback of your experience. As I am a shy guy, that's why you may face audio disorder or communication gap. Please like and subscribe.